Okay, so you're all very welcome to the fourth and final webinar in this series being run by the Decade Coordination Office for Ocean Data Sharing as part of the UN Ocean Decade activity. I just want to acknowledge once more the funding that the Decade Coordination Office has from Fondation NG. And their support allows us to put on sessions such as this one. We're lucky today to have a couple of speakers with us. Rob Thomas from the Marine Institute in Ireland, and then also Bob Currier is here as well, and Bob will talk towards the end of the session today. Bob is from GCOS, and so what we will do, we will pass over to Dr. Rob Thomas first. Rob has been a marine data manager for about 20 years now, working at first the British Oceanographic Data Centre and now the Marine Institute in Ireland. Rob's going to talk to us a little bit about how the application of standards to data sets in data sharing software, such as the ERDAP software that we've been talking about through these webinars, can really enhance the products that you can build on top and to allow the analysis to continue in new ways. So, Rob, over to you.
Thanks, Adam. Can you hear me and see my screen there? Okay, yep. Good stuff. Okay, so yes, so Adam invited me today just to talk about sort of what we've been doing with regards to data standards and enhancing the metadata for added value, and in that aspect, I kind of mean around the user experience of finding data through tools such as ERDAP. So clearly, just a little overview to start with. What we're going to look at, is a bit about standards, some formats, some vocabularies, and then when it comes to improving the user experience, I'm going to kind of take my life in my hands in terms of presentation and try for a live demo of a couple of things that we have built and utilised. So I'm very aware that when it comes to talking about standards, that can be a very dry conversation. And we don't want to be sat here looking at PDF pages describing technical jargon. So just to reiterate the importance of standards, I just want to return to a slide that any of you who've seen me talk before will be familiar with. There's this idea that the same word or the same terms or phraseology can actually mean different things in different locations and different communities. So just in this one here about volume, you can see that even within just Australia, depending on what you ask for when you go for a drink, will result in a different volume, different size beverage. And so we face the same situation when we're working with data, even within an organisation. And a lot of the problems I've tried to look at within the Marine Institute are probably a microcosm of the larger global issues when it comes to aggregating data or being able to search across data sets. So when we started looking at this in jointly with the EMSO ERIC working group here in Europe, one of the research infrastructures, started looking at the ocean sites data format. You might remember in the first week, Kevin O'Brien made reference to ERDAP starting out or being built on top of the kind of CF, NetCDF format. But as these things evolve, different communities need extra things or extra elements. And so what we started off with was looking at the ocean sites data formats. Reason for that was in Europe, where we're based, there are a number of different communities, and it seemed like the ocean sites format was actually the baseline for the CDataNet, NetCDF format. The EMSO ERIC have taken that standard or format and enhanced it for their purposes. And Copernicus as well use it as their kind of base format. And then there's other communities like CDataNet where ICs have a slightly different variant on that format. And even then globally, the WOS exchange format, when we're submitting our ocean acidification data to GloBAP, it's again a slightly different flavor of structure or content. So coming back to the analogy earlier, again, you start off with one item, and then different communities evolve that into effectively different flavors for their needs. So we wanted to look at how can we consolidate this data, this metadata, and present it out so that we don't have to have different versions for different communities. And so looking at this format, guidelines, and this reference manual, there are a couple of areas that we kind of looked at for our needs in particular. And I'm going to highlight those. So the structure of this is such that you have the global attributes around the data sets. Those of you familiar with the NetCDF structure will recognize that. The coordinates being the X, Y, Z, and T, latitude, longitude, depth, or height, and time. And then data attributes on the actual data variable within there. And makes a good job of calling out things like quality control, sensors, how they're deployed, and then uncertainty, accuracy, precision, and resolution, which going forward we're going to need for essential ocean variables assessments. So one area that we chose to enhance ourselves it is around location. Within the ocean sites format, there's a sea area attribute, which is populated from the Seabox water body gazetteer. Ourselves being based in Europe, there are other legislative reasons for reporting or aggregating data. The International Commission for Exploration of the Seas, Water Framework Directive, Marine Strategy Framework Directive, Shellfish Water Directive. And so we have at different times, different people coming to us looking for data under these different areas, which whilst maybe named the same thing, in terms of you put here Celtic Seas in one and Celtic Seas in the other, are actually slightly different. So we're enhancing our metadata, which is available through ERDAP, to link to these defined polygons which have a name. The advantage here is that it also makes the data searchable for people that are looking for more local versions of data or local areas of data. The next thing we've looked to enhance is around the parameter and how the data variables are being described. So there's two examples here from two different vocabularies that are commonly used. One is the Sea Data Net, widely used in Europe to describe salinity measurement. The other one is the CF standard name. Using knowledge graphs that exist, we can build out from that to provide a hierarchical search. So both of these terms link back to a discovery vocab at the higher level of salinity of the water column, higher again water column temperature and salinity, and higher again at physical oceanography. We can then link these parameters to the essential ocean variables or climate variables, and in Europe, the MSFD, Marine Strategy Framework Directive, linking out into the indicators, criteria, and descriptors. And that all comes from just linking in this one place. We can then infer and inherit this other information. So I'm now going to jump into a quick demo. What does this mean for what we can then do with the data? So through ERDAP, we publish these metadata out. We can then build a search functionality across these facets. So this is just an example here of a dashboard we put together in Microsoft's Power BI. I should say other dashboarding software is available. So the idea here is that we can pick down through the different areas. So in this case, if we are looking particularly at coastal data, this now subsets down to show us what data is available. It gives us a breakdown of our ERDAP data sets, showing which data are relevant to that search. And then we can link out based on the data aggregations to data catalog records. And also we can provide a link. So you can see there that using the search facets here, this has now built the download link to the ERDAP dataset underneath. And by clicking on that link, oh, always pick one that doesn't work in a live demo. I'll bring that back. this one. As I said, live demos. The idea being that that would then be able to give the user a link through and a download to the data underneath. Again, we can search by dates and times to refactor the data. And then looking through the hierarchy, we can take a look and see, right, what do we have in terms of chemical oceanography, let's say the carbonate system. Right, so these are the water samples we have. And we can also then see what the geographic coverage is, what the temporal coverage in terms of the data that's available for download. So let's have a quick look again. And again, we can look by Atlantos name. So let's say salinity. It gives us a breakdown. These are the data sets that hold salinity data. And if I click on this one again, third time lucky, yeah, we can see the downloads coming in. So we're searching across a range of data sets that are within our ERDAP instance, and providing to the user an easy way to subset to get what they need back without having to go data set by data set through the ERDAP interface. The other nice thing that we utilize ERDAP for is for our real-time data from the DigitalOcean. And so each of these locations are feeding real-time data, and we're able to call out and build applications on top of the data to give our users access to the data without even really knowing that they're using ERDAP itself. ERDAP is great as that middleware, but this enables us to provide a friendlier user experience around gaining access to our data sets. And I'll just highlight here. So this is an example, and I'll pop this in the chat afterwards. This is an example of an enhanced metadata data set where we've pulled in the different attributes from a number of different sources that are required, and then marked down the extra water bodies and enhanced the variable metadata. So you can see here within conductivity, we're able to report accuracy, the different sensors, and by adding in these different hierarchical vocabularies in the data in the ERDAP setup, you can then go in and add those vocabularies to the subsetting tool. So here in this particular ERDAP instance, again, as before, we can highlight the carbonate system because it's there in the metadata, and the user gets back which of the data sets contain variables that are relevant to the carbonate system coming off the essential ocean variable names, or again, using the CDataNet hierarchy. So we can pick out those that have biological parameters in, chemical, and the like. So those are just a couple of examples of how we're enhancing our ERDAP metadata using the standards around data formats and the metadata, and then linking to vocabularies which are involved with, which are set up within knowledge graphs, so we can leverage those knowledge graphs for ultimately the user experience of being able to identify which data are actually relevant to their needs. So I think I'll wrap up there, and I don't know if you want to take questions now or at the end.
No, we'll take questions at the end. Thanks, Rob. That was a really good overview of the work that's happening there in the Marine Institute and around how standards can be really helpful in providing things for providing better access to the data. So if you do have questions for Rob or for Bob, then please do put them into the Q&A and we'll take them in a moment. But now we'll hand over to Bob Currier. Bob's a full stack AI automation engineer with over 30 years of experience transforming cutting edge research into production grade applications. Currently, he's the principal data scientist at Texas A&M University's Department of Oceanography. and particularly working on the Gulf of America Coastal Ocean Observing System, GCOS, specializing in real-time oceanographic intelligence and autonomous underwater vehicle operations. Bob's going to talk to us about ERDAP to MCP, which is about making ERDAP accessible to AI assistants. As we've heard from Rob and from all our speakers through this webinar series, ERDAP is a powerful system for accessing oceanographic data centers. But as Rob so nicely pointed out, it's complex and may even require technical expertise in order to use it. And so scientists want to focus on research and not wrestling with data access protocols. Rob showed us a dashboarding approach to that, and Bob's going to show us an AI assistant approach to that. Over to Bob.
All right, thank you, Adam. You can hear me okay? All right, let me go ahead and share my screen. Let's go to screen and look good. All right. Well, thank everybody for attending. Looks like we have a really good crowd out there. I see a few familiar faces. I saw Ben Best out there. So hello, Ben. It's been a while. I'm going to talk about ERDAP to MCP. And this actually, it's one of those projects that I didn't start out to build. I was actually almost goaded into doing this by one of my colleagues at GCUS. And he built a ERDAP to ArcGIS online tool. And over the course of a few months that allowed users to query ERDAP servers and have all the data automatically turned into ArcGIS layers. And he did a really good job and he got a lot of favorable responses. And he kind of drew a line in the sand and said, I dare you to do something better. So I had to come up with something, and this is the result of that. So as you mentioned, two different approaches. This is trying to make ERDAP more accessible to non-ERDAP literate people, particularly K through 12, teachers, the general public, and life scientists. I think everybody knows what ERDAP is, created by Bob Simons. It's been around for a long time, supports just about every format that you want to get your data back in, but that's what adds to the complexity. And so enter MCP. And MCP is relatively new. I believe Anthropic dropped it in late November of last year, so less than a year old. It stands for Model Context Protocol. The origin story of MCP is that all the AI vendors were realizing that they needed to give their LLMs access to tools, and they were building the tools in, and everybody had their own way of doing it. And finally, as was true back in the early days of the internet, with RFCs, people said, why don't we standardize how all that works so we don't have to reinvent the wheel. So they open sourced MCP, and it standardizes LLM to tool communications, enables Claude in particular, GPT supports it now, access to external tools and data. Anthropic likes to say it's like USB-C for AI. Those of us that build MCP servers usually prefer to say it gives AI wings or fingers. So it gives AI the ability to actually reach out into the real world and do things. So why ERDAP to MCP? As you've seen, ERDAP is powerful, but it's complex. And a lot of my colleagues are not data scientists or computer scientists. They're biologists and fishery scientists. And they don't want all the data in the ERDAP server. They want one particular thing. And if you don't use it on a regular basis, it can get a little bit frustrating trying to figure out just how to get the data that you want. With the rise of the AI assistants, agentic AI, that gave us the opportunity to really make the access much easier. So my application supports two methods, either via a local server, which means it runs on your PC. You need to have a Claude desktop client. The free version does work. Or it can run, excuse me, it's also running out in the cloud on a service called fly.io. The functionality is exactly the same. The advantage of using the remote server is that you don't have to go through the virtual environment, pip install, and everything to make your local system compliant. There is one file that needs to be modified, but it makes it a lot easier for the IT team to get it deployed, but no functional differences. So the core tools are list servers, search data sets, get info, and convert everything to pandas. It's all read access. There's no write access unless you're really brave. Giving MCP tools write access to your data is not generally a good idea because sometimes they go off and do their own thing. So the deep dive into the local versus remote, and I'll try not to dwell too heavily on this. The local server, everything is via standard I/O. Cloud Desktop handles all of it. It's almost instantaneous. It's a bit harder to set up and get running. The remote server is via HTTPS streaming. We do support OAuth authentication, even though it's not currently implemented, but it allows me to deploy that out there and then everyone to take advantage of it. Excuse me. So the key differences are at the time of the slide deck, Cloud Desktop only spoke standard I/O, so you needed the shim to make it work remotely. I think they've changed that, but I haven't investigated. So we'll get to the using it part as quickly as I can. Again, to install it locally, it's a standard pip install, and all this is documented ad nauseum on the repo. So there's pages and pages of how to get this going on the GitHub repo. So you configure Cloud Desktop, give it the Python command if you're using a virtual environment. It's going to be your path to the Python in the virtual environment that you've set up, and then the path to the RDAPI MCP server. Windows users, a different method, but still basically the same. Restart Claude, and you're good to go. If you're using remotely, there's one more installation that you need to do. You need npm, which requires Node.js. Again, a fairly straight installation. Now we get into the usage. So I have slides of samples. I'm also going to take a deep breath and do a short live demo at the end if I have time. I tested it, it works, but it's been 10 minutes, so who knows what happens. So instead of having to know what you're looking for, you can say, show me the available RDAP servers. And when this slide was done, I had 5 primary. Now I have all known RDAP servers in there. So there's about 65 RDAP servers that you have access to. And in this case, I said, search for glider data sets on the GQ's RDAP server. And it came back very quickly, found 26. It gave me a list of the names. And the really nice thing about the LLMs is that they give you what you asked for, but they try and be helpful. So they provide a lot more context and try and explain the data that they saw. So here we have it telling us that it contains oceanographic measurements collected by gliders. So then I asked it to search the server for data sets created by me. And it found 26, gave me a list of all of them, tells me, again, they're glider data sets. Would you like more information? Would you like to see the complete list? So I gave it a rather generic query, again, just to show how flexible it is. Okay, use the data set ID, do a test, give me detailed output so I can show my colleagues how cool this is. And it went out, queried the RDAP server, and then came back and gave us a nice overview. That was a University of South Florida glider, had a 12-day operational time, gives you the date and times, the mission coverage, the latitude and longitude range, the instrumentation package that it carried, and all of that. And then you could drill down farther and say, well, I'd like a temperature profile as a scatter plot for 5 days and give it the date range. And if you're using Claude, it'll go out, build an artifact, and give that to you. And this slide is might be a little bit out of order, but it follows my last statement that I used this. It took about 10 minutes and asked the tool to find me Asian current data sets in the global RDAP network. and it came back and said, well, it looks like the PML, which is NOAA's specific lab server, has the most data. How about Rama? And I said, sure. And so it went out, queried the Rama data sets, and came back. And I'd asked it to build me a heat map, and it did its thing and generated an HTML artifact that is not live on this, but it is live if you save the file. So it's several months worth of data from the Rama buoy network around India and in the Indian Ocean. You can click change vectors and do all of that. So I went from a simple query to a presentation-worthy plot in no more than 10 minutes, excuse me, without knowing where any of the data lives. In addition to ERDAP, what we have coming soon, it's built, I just haven't released it yet. The same thought process for Copernicus. So we now have access to it's almost 300 data sets through the Copernicus Marine Toolkit. When you first run it, it queries the toolkit, gets a list of the data sets, and then caches it locally. And then the next time you run it, it only looks for diffs. So it really speeds up the initial queries, but exactly the same methodology. So instant access, it's smart downloads, it does spatial and temporal subsetting, creates the visualizations for you. You can use it for anything you would think, analysis of water conditions, wave models, current models, climate monitoring, and all of that. I'm about to release the repo for that. Excuse me, and it will be exactly the same. Install the tool and you'll have access. But in the process of building that, and this is the real caveat with the LLMs, I ran into this problem. And that in the next plots that I'll show you came about because I was on a call and one of my colleagues said they were about to deploy a glider in the Gulf of Mexico. They'd ballasted the glider about a week earlier, and there'd been a lot of freshwater runoff. So the water density had changed. And he wanted to know if I could do a surface density plot so that he could pick the most suitable area to deploy the glider, since it likely was not ballasted for where he was going to deploy it. So I did, and I got a lot of hallucinations back from the LLM. And here is the conversation that we had. It confidently assumed that it had density data sets, and it just made stuff up. So you still need to be careful. There's still a need for a human in the loop. It tries to be very helpful, and it's gotten a lot better, but occasionally, it'll still make stuff up. So I rewrote the code in the middle of the meeting, got the variable names in there, and pardon the language, but that was the response. It was very pleased with itself when it figured out, wow, I can see all the variables now. Now I know what to do. So then it went ripping out there and pulled everything together, continued to get really excited, and found the density of ocean surface and salinity. And then in about 3 minutes, it whipped these plots out for me. The meeting was still ongoing, so I was able to share them with my colleague, and he used the density plot to redirect their deployment out there. So that literally was in 20 minutes using Copernicus. And as I mentioned, we deploy on Fly.io. And the beauty of Fly.io is that they're global, and they use their own DNS to route you to their mirror data sets that are closest to you. So if you're in the UK, you don't have to come all the way to the US for this to work. It routes it to a data center closest to you. And do I have time, Adam, for a quick demo, or am I out of time?
No, go for it. You've got 10 minutes, I would say, if you need it.
Yeah, I'll give it a try. So holding my breath, I like to refer to it as Schrodinger's demo. It works until you show someone. You can't tell if the cat's dead or not until you actually look at the cat, and then that changes everything. So let's see if I shared my whole screen, so this should work. Let me zoom this up. Is that visible? Okay.
Yes.
So I did a little preloading here. So I asked it to use the GQ's ERDAP server and find data sets with me in them. It went through, got a 404 error, which I'm seeing some of, and that's ERDAP servers saying, "Hey, you're asking too many questions too quickly. I need to work on some settings for that." But it did find me, came up with all of that. So let's say, what can you tell me about the data set with USF, Gansett, and Red Cod research? Fingers crossed. And can you give me an average surface water temperature for the last 3 days of the deployment? It doesn't have to be exactly at the surface if that data is not available. But I know typo should be under, should be no more than 2 meters. Let's see how it does. So it's pulling the data down, going to convert it to pandas. It's a demo, so it's not going to work. Yeah, it looks like we're getting 404 errors.
Well, this is the kind of thing that does happen when you risk the live demo. Not not to worry at all. If we get anything back, then we can always come back to it. If anybody has questions for Bob or for Rob while we're waiting to see whether the LLM comes up with anything, maybe stick them into the Q&A. I had one for you, Bob, which was for your kind of list servers function that you have in ERDAP to MCP. How do you maintain that list of known ERDAPs for the connection to make? Because there is a list on the awesome list. Yeah. On GitHub. Yeah.
Yeah, it's from the awesome list.
Oh, cool. Yeah. So then, maybe what I'll do, I might just dump into the chat the awesome list. It would be great if anybody who's running an ERDAP server, if you could add your server to that awesome list. Tools like Bob's ERDAP to MCP, but other tools that we've developed around the ERDAP community use that list to to drive their cross ERDAP searches and other things as well. So keep adding your own ERDAPs to that is really important, and there's instructions for doing that. Let's just see Q&A. So I mean, Ben asked. Well, I mean, Rob, you answered it in the Q&A, but maybe you could answer it live as well. In terms of the dashboard, then you showed maps and spatial coverage. What kind of tech are you using there to make that happen?
Yeah. So the dashboard was built here using Microsoft Power BI, and within that you effectively have pre-canned plots and sliders, structures. So it's one of their map widgets, and then you just point through the graphical interface. You point to the columns in the metadata tables that you've generated to provide Latin log, and then it renders.
Right, and there's a couple of questions for Bob as well. First one is also from Ben Best. Have you implemented the Adaptive MCP on a publicly available server, considering the non-technical users are wary of installing? And yeah, presumably Claude will generate R or Python notebooks applications as artifacts too, and could generate output on the server.
Yeah, it's available via the fly.io server, which is documented in the repo. You still need to modify the Claude desktop config JSON file. There's no way really around that, but that does make it fairly straightforward. My goal is really to move it away from a dedicated desktop client like Claude or ChatGPT, and I've built a purely bespoke agent for an Asian client that's fully web-based, and so all that code uses one license. But in the matter of doing it like this and then making it open to the science community, we've got to have funding to pay the token costs for Anthropic for doing that. But by doing it that way, then you remove any local installation at all. It's just a web URL, and you drop right in and go. So
yeah,
if we can find the funding, that would be the direction that I'd be taking this.
Brilliant. Thanks, Bob. And there's another question then. What's the workflow to get out of Claude Desktop? Meaning, once you call the MCP server and think you've got some data that you want to process afterwards, what do you recommend?
You can just ask it. You can say, pull the data and give it to me as an Excel spreadsheet. Or if it gives you a table to look at, then you can say, a lot of times it'll provide a download link as a CSV or an artifact in there. But basically, you just ask it, and it'll either generate the file if it knows how. But lately, because there are a lot more good Python tools for doing random file type creation, it more typically says, sure, I'll give you a Python script that you can run that will do that for you with my answer, and then you run that and get whatever it is you're looking for. So basically, just ask.
Okay, great. Any more questions? So Roy had said that there are lots of other apps that we know about that aren't in the awesome list. Yeah, and I get that. Really helpful to have a centralized list of those, though. So I think if we can encourage people to adopt a central list and to submit their own to a central list, then that's also really helpful, especially when we have tools that are trying to draw on that knowledge. So yeah, I mean, I get you, Roy, about not adding other people's apps, but yeah, the best we can do to try and find ways of doing that, I think, is really helpful. Rob, I had one more question. Relates slightly to a deep conversation that we had last week about essential ocean variables. Maybe you could just talk a little bit about how that hierarchy works and how that kind of mapping from the real detailed temperature description that you have in the CDataNet parameter usage vocabulary goes into an essential ocean variable, and then how that is maintained to some extent as well.
Yeah, so I mean, yeah, we're talking on behalf of our former employer, I suppose, a bit there. The Node Vocabulary service is managed by the British Oceanographic Data Centre, and they would house the mappings that exist on the Node Vocabulary server. the mapping that I showed was based on the Atlantos essential ocean variable mappings, and they were in effect done by hand between the relevant what we term P01, so the parameter usage vocabulary. Under subsequent projects, I know that the team now have in effect put in looked at the specifications that were issued by Goose around the essential ocean variables and have made them more dynamic. So what we're mean there is, if somebody requests a new parameter code related to temperature in the past, they would have had to ensure that they then map that, if appropriate, to the essential ocean variable. Now they're looking at how the semantic model in the background of the vocabulary term, those components, how they fit to the EOV specification, and so that mapping is now generated dynamically. And I think it's worth saying that when we're looking at this is your EOV relevant parameters and data, because depending on the specification, there is a level of uncertainty about the measurement that's required in order to make it an essential ocean variable or essential climate variable. And so you're not going to get that from just the parameter codes on their own. You have to link that in with the uncertainty that's reported for the data set. So does that give you an answer? I think that's where you're looking for.
Perfect. Yeah, thank you. All right. Well, I think if there's no more, I don't see any more questions either in the chat or in the Q&A. I'd like to thank both Rob and Bob for some really interesting talks today, and also all our other speakers from the previous 3 sessions as well. Yeah, thank you all for joining. If you would like to follow along with the work that the Decade Coordination Office for Ocean Data Sharing is doing, please copy that QR code or scan that QR code that's on the screen now, or go to LinkedIn and search for Decade Coordination Office for Ocean Data Sharing. We would also love to hear some feedback on the last 4 weeks from you. There's a form that is linked in the chat right now. So please click on that, fill it out. We'd love to hear topics that you might have, suggestions for follow-up webinars and other things that you'd like to hear addressed in webinars. We will be organizing another webinar before the end of the year. It will not be a technically focused webinar. It won't be a ERDAP webinar. It will actually be on the findable, accessible, interoperable, reusable FAIR principles, and then the CARE principles for indigenous and local knowledge. And we will be having a speaker who's really focused on bringing both FAIR and CARE principles to field stations in coastal zones. So it's kind of a real change in direction for the webinars after these very technical deep dives, but also really important topic, especially with the work that we're doing across the UN Ocean Decade. So thanks everybody for joining. Thank you for taking the time to follow along on LinkedIn and to fill out the form as well, to give us some feedback. And I hope you have an enjoyable rest of the day, and we hope to see you at some more events that we run throughout the rest of the decade. Thank you.